Okay, so last for the 3x3 matrices, it says, do I have to use the first column to find the determinant for every 3x3? And the answer to that is simply no, you do not. Okay, you should select the row or column that has the most zeros. That has the most zeros. Let's rewrite that one more time. Sorry about that. So, if you notice, it was add, subtract, add, right? So if you decide to go somewhere other than the first column, if you chose like the second or third column, this pattern plays true every time. So plus, minus, plus, minus, plus, minus, plus, minus, plus. So you notice it just alternates. So if I were to go with the third column, so let's say I use this column right here. So what would happen is whatever this value was, it would be positive, then the determinant, then if I go in minus, then the determinant, and then plus, and then the determinant. If you decide to go with the second column, so I'm just showing you examples. So if I went with this column here, it would be minus whatever that number is, then the determinant, plus whatever the number is, then the determinant, and then minus the number, then whatever the determinant is. So you can see that the pattern would just work out either way. So you always want to pick the one with the most zeros when you're doing a 3x3. Okay, so an example of this, example 4 right here, evaluating a third order determinant, which once again is just a 3x3 matrix. So with this here, what I noticed first off is that this column right here has by far the most zeros, okay? So if I think about the pattern, I'll do this here. This would be plus, minus, plus, minus, plus, minus, plus, minus, plus. Okay, so now I can see that this is plus, minus, plus. So I'm going to do the determinant. So this is positive 0. And I'm writing this for my determinant. Minus 0. And then my determinant. And then plus, that's a positive 2. And my determinant. So just like before, we start with this first 0. Let's get rid of this first row and third column, and hopefully you can see that we have -2, -3, 1, and 4. All right, now I'm going to go with the second row, third column, and we see we have left 9, 5, and 4. 9, 5, and 4. So 1, and 4. And then with the last one, the 2, we get rid of the third row and the third column, and hopefully you see right there you have 9, 5, -2, and -3. Now, what this allows you to do when you have the most zeros is this. Regardless of whatever this determinant number comes out to be, it's going to be 0 because 0 times anything is 0. So I'm just going to work it out either way. So we do diagonal multiply and we subtract. So -2 times 4 is -8, minus 1 times -3 is -3, so this becomes positive 3. Minus 0, 9 times 4 is 36, minus 1 times 5, which is 5. Positive 2 times 9 times -3 is -27, minus -2 times 5, which is -10, which becomes positive 10. So regardless with this will be 0, minus 0, plus 2 times -27 plus 10 is -17. 2 times -17 is -34. So there's your determinant. So it's a lot easier when you have multiple zeros in there because that allows you to just get rid of those quickly and you're really just working out one part.